Okay, hello and welcome everybody again to this Eurodoc Open Science Ambassador training. This is webinar number 5, looking at data management and the fair data principles, as well as implementing a data management plan. We have Paola Masuzzo, who's going to give us her expertise, opinion on this topic. Very quickly, before we go to Paola, I'm just going to give a brief introduction to what we're doing here and why we are doing it. So the idea behind this training course is to train approximately 30 open science ambassadors for Eurodoc, for our national associations, who know what open science is and who can explain to our researchers the different aspects of open science, as well as engage our national and European stakeholders on open science. Now, Eurodoc is a non-profit organization based in Brussels, legally for the last 16, 17 years now. We have currently around 29 national associations, and these are basically organizations representing doctoral candidates and postdoctoral researchers. They are funded exclusively by their members, and they're run exclusively for their members by early career researchers. And what we basically do is develop policies and engage stakeholders on topics that are important to early career researchers. So the topics that are relevant for them that we have identified, at least over the last few years, are number one, career development, especially for the non-academic labor market, given that most early career researchers must leave academia. Number two, mental health issues, or the increasing awareness of mental health issues in academia. We've seen studies emerging where over 40% of doctoral candidates are showing signs of stress and anxiety, and 30% are showing signs of clinical depression. So this is linked to the uncertainty in academia, to the high pressure and publish or perish environment, and it's something that certainly needs to be addressed. And then the final issue that we are trying to deal with now is open science, and also the reason for this series of talks. So open science, what do we mean? Well, we've been doing this for around 400 years, and basically when we talk about open science within a European context, then we are talking about a document that came out of the European Commission in 2016. And they identified what they call as the 3 O's. So open science, this is basically opening up research using new digital tools and technology. This is linked to open innovation, so pulling in stakeholders into the innovation process, creating new services and products using open science. And this is further linked to what's called open to the world, or basically opening up our research, opening up our market to non-European stakeholders, and also including society, and gaining more impact for what we do. Now, when you ask people what open science is, each individual will give you a different answer. What we mean here is basically a suite of different practices, including but not limited to open access or open fair data, or for instance, open education or open evaluation, open licensing, open methodology, open source, and citizen science. So quite a lot of these different practices. Now, why should we do this? Well, basically, it opens up access to our research results and to our research publications. It increases discoverability. It also increases your own impact, as well as the social impact of your research. It helps reproducibility. And for limited researchers or institutions, it helps them pool together their resources and work together, and ultimately speeds up innovation. Now, to be clear, when we say open, we do not mean black and white, open or closed. We mean a spectrum of open, where we try to be as open as possible, but understand that there may be reasons to be less open, for instance, for medical or private data, or military national intelligence, or also for some levels of commercial enterprise. And just to close off, Eurodoc fully supports open science for several years now, and we have identified that most researchers do not fully understand what open science is, that they're not being trained or supported for this, and crucially, that they're not being rewarded for this in their career progression and in their research evaluation. So this is something that we push strongly for. And just to give a plug for the Foster portal or the Open Science MOOC here, if you're more interested in the courses, then you can click the links and find out more about that. Before we go to Paola, I'd like to quickly switch to one of the organizers of this training, Ivo Grigorev. Ivo, I'm going to pull you up. I know that you're at the ETU, European Theological Union. Can you tell us what was going on there?
Hi everyone. How is the audio? Can we hear each other?
Yes.
Great. So let me just put the camera on. I don't think you can see me. Anyway, let's keep this short. The reason I want to steal 3 minutes of your time is just to echo something that Gareth finished on the reward system and also touch on Plan S, which is your next webinar with a brilliant presenter who I just saw yesterday. So I'm at the European Geoscience Union. Just to give you a sense of scale, this is an annual event, a week-long, 15,000 attendees from the Earth and atmospheric and marine sciences. And this is a society that's very open science progressive. It holds and organizes 90 plus peer-reviewed journals, all of which are open access gold, um, and also all of them practice the open peer review mantra down to the bone. So this is an interesting forum, and yesterday they ran two debates. One of the debates, uh, both debates were attended 100 plus audience, a lot of young researchers. One of the topics for the debates was Plan S. I'm not going to steal the founder of the next webinar. Suffice to say two things. The presenter you will have next week, next webinar, is Mark Schlitz, who is the head of Science Europe, and that's an association of funders. So that gentleman speaks really on behalf of the funders, and I just want to throw one message at you. There is a lot of misinformation on Plan S, and the publishers are guilty. And that became very evident yesterday in plenary, where both the community and the funders reacted violently against the subscription publishers. So, if you, in your ambassador work, get stuck on Plan S issues, it is a sticky issue. I would defer to Science Europe statement. I would defer to what Mark Schlitz has to say to you next webinar and take that as the truth. There's a lot of misinformation on the publisher side, be it um, by design or by misunderstanding. So just to be aware of that. The second issue I wanted to bring up is really concerning early career researchers. The second grand debate that was held here was about the reward system that Gareth just mentioned. And one of the key questions that rang pertinence with myself and it will with you as you start your ambassador work is what does an early career researcher do if they are convinced about open science, but they go back to a lab that is agnostic or aggressive on the topic? And I think the whole room, a lot of the panelists vocalized the advice that I think Gareth, I, and Roberta would like to pass on to you throughout this webinar series, and that is a young researcher that is convinced and courageous to push the system towards open science should do that as far as it doesn't get them into trouble. So I think the main message is stay open, but stay out of trouble. At the end, they want young career researchers to stay in business in order to change the system rather than get in trouble and get kicked out. So that's all I wanted to say. Far too much time. Don't miss the next webinar. It will be a great one as well as this one. So enjoy fair data.
Thanks, Ivo. Then I'm going to pass the floor directly to our data superhero, Paola Masuzzo. Paola, I've got you the floor now. So thank you for doing this, and we're looking forward to hear about fair data and data management plans.
Thank you very much for the introduction, and thank you for having me. This is a really nice opportunity, I think, because there's a lot of discussion going on, and fair data is and data management and data stewardship is certainly one of the biggest topics right now. So if there is one message that I hope this webinar is going to give everybody is that research data are first-class citizens in science. What I have seen, what I've shown here is a cartoon that basically highlights the scientific method that you must all know, be very well of, where you go from formulating an hypothesis and then all sort of things that you need to do in your everyday research until in the end you can report the study. Another way you can look at this, if you put everything kind of in a horizontal pipeline, you go from your last manuscript, so actually the piece of story you have put as an output of your research plan. And then basically, if you look at the reproducibility spectrum, you can say that what the actual manuscript, the article does, it's just advertising. It's important, but it's not actually where the entire science lies. The entire science is the text, plus the data, plus the code, plus the research workflows, plus the tools, and even the versioning and the analysis code. So research data do not need to be underestimated. Of course, the real question is who cares about this data to begin with? Now, I know you've already had a very interesting webinar on e-science and what it means to do science nowadays in your FAIR Principles webinar. But basically, the short answer is that everybody who has a little interest in modern science is and needs to be interested in research data as well. So you have on one side the researchers and machines that need to discover data, having a certain amount of features of interest. So for them, we need to have links, metadata. Once the researcher knows that the machines are sitting somewhere, the machines need to have a copy of the contents in some format. And then finally, the researchers go back to their desk, they start analyzing the data. And for those, they need to have workflow tools that are capable of aggregating data, check the sanity of the data, and so on and so forth. Now, of course, this entire scenario is not simple, it's not as linear as it might sound, because it's an ecosystem where different players have a role, starting from researchers, so each of you on your side, ready hopefully to share your data, to share your interpretations. Downstream, you have professional data publishers, like data repositories and data journals, funding agencies, and then an entire data scientist community, to which, for example, I belong to. I love data, I love doing data science, and so we need to be able to optimally reuse research data and methods. This is a challenge, but somebody has come to the rescue. So for a substrate for knowledge discovery, what you need to have are machine-readable data and metadata. And so far, the community has agreed that the best practice recommendation is to be as open as possible and as fair as possible. And we will see in a moment what this means. So basically, if we go back to what I've just shown you before, data, when I talk about data, I talk about research objects. Research objects, it's any unit of scholarly information you can find on the web. And basically, the idea is that everything that belongs together, for example, an article with all the data, the code, the workflows, like I've highlighted in this slide, should have some means of being aggregated, so that when you as a researcher go interrogate the web to find back whatever is linked to that article, you actually find it. This seems obvious, but these pieces of information are scattered across the web, so it can become a huge mess super fast. And this is, for example, something I've personally experienced in my PhD. I will go back to my personal story about research data in a little bit. So you already know by now what FAIR means: fundable, accessible, interoperable, and reusable. We will see practical tips for the implementation of FAIR for research objects. Just a little disclaimer at this stage that I would like to give you, but I think you also know it by now, is that FAIR does not mean open. So the A and the reusable do not necessarily mean open. FAIR data and open data can overlap, but they don't have to. These FAIR facets are completely, to some extent, independent of each other from a technical point of view. So we can talk about degrees of fairness, and we will see that also later on. And the FAIR principles, like they have been introduced in the scientific community, are completely agnostic of technical implementations. This can mean that can be achieved with different implementations and technologies. So we will now go and look at the four principles: the F, A, the I, and the R, and we will see some tips and best practices for each of these. All these tips and best practices I'm going to give you are based mostly on the personal experience of my PhD in computational biology. Had to look at data, had this fantastic idea at a certain point to develop algorithms that would mine data already published out there. And I soon realized that this was before the FAIR principles were introduced, that this was not possible. So you will see now how things have changed in the last couple of years. What does it mean findable? The most important thing is that metadata are assigned a unique, globally persistent identifier. So what we call a PID, a persistent identifier, so that machine can locate the dataset. Throughout this webinar, sometimes I talk about data, sometimes about metadata. Most of the things I'm going to say apply both to data and metadata. So I will use the generic term research objects or data. The most common mistake which is made at this stage is to say, okay, I have a URL, I will just tag along with the URL. But the URL is not separated from location. So the URL points to a location of a research object of a web document on the web, which basically means that if you move for any reason, you don't have the money to support a website anymore, you just do a change completely of your website or whatever. If you move your web document, the URL will point to a wrong location and you will find the famous 404. So the best practice in this case is to use to deposit your data and your metadata into a repository, which will give you automatically a persistent identifier. Look for a domain-specific repository. If that does not exist, you can go for a general purpose one, and I will give an example in a second. Just to resonate a bit with something that we see in our everyday life, what is the most widely used persistent identifier for research data? A DOI. So when you have, for example, your article, your scientific article published in a journal, this has a unique DOI, but of course then different URLs, depending on the database, depending on the preprint server, and so on and so forth. The URLs can be multiple because the locations of that document are multiple on the web, but the DOI is unique. And for long-term preservation, that's critical. I'm just gonna show this because this is the PID graph, which has been introduced recently from the data description registry interoperability. That's a difficult word. Working group of the Research Data Alliance. I'm a Research Data Alliance member, and basically the idea is that to show you that if you put the PID, persistence identifiers, in a graph, you can represent many different contexts and you can enable discovery and impact assessment at the same time. So this goes a bit back with what Ivo was just saying. How are we going to assess that whatever you have shared actually has an impact? How can you get rewarded? In the first case, you are tracking different versions of a software code that you might have written. In the second case, the B, the yellow, the data sets that are hosted by particular repositories are linked together. And in the third case is exactly what I've shown you before, all digital objects connected to a research manuscript. Now, findable where, as I said before, you have domain-specific repositories, but also general purposes one. So you should definitely look for something that goes close to your domain. You don't have to know them by heart. I don't. The most valuable resource you can use is the re3data.org, the Registry of Research Data Repositories. It has a huge list of certified repositories online, or you can use the databases listed in the FAIR sharing catalog. If you do not have a domain-specific repositories, then you have things like the Open Science Framework of the Center of Open Science, Fixture, Zenodo, and so on and so forth. Data are metadata. This is also super important. I believe together with the persistence identifier, this is a crucial part for a data set to be findable. So what does this mean? I always like to talk about this sentence, which is now in the open community for some time. Nobody says who said it first. Your first collaborator is yourself, and your past self does not answer emails. So do not think necessarily that you have to annotate your data because somebody is going to use them. You might want to reuse your own data 6 months from now, 1 year from now, 2 years from now, because in the meantime, you've acquired more knowledge, you have become smarter, you can use tools and techniques you could not use in the past. So in this case, the tips are never presume to know who's going to use your data and for what, so be generous. If you think this metadata is not needed, put it down. Whenever possible, use community standards, and have someone naive check your annotations. So this is also something that I did through my PhD. Whenever I had to publish a little piece of data or metadata, I would go to a research group working on a different research project, a different research line, and I would ask them, does this annotation make sense? Mostly the answer was no, but that's because I was a student and I was still learning a lot. Number 3, if basically data metadata needs to be linked through a persistence identifier, but this, if you do F1, if you put your data into a data repository, if you do F1, F3 comes for free, you don't have to worry about that. So accessible, what does accessible mean? Basically, the first principle, which is A1, which is then scattered in 3 little pieces. This means that everyone, if it's authorized, so keep this in mind because we will go back to this in a second. Anyone with a computer and an internet connection with a well-defined protocol that you give them, that you publish, can have access to your data. This does not mean that your data is open. You can also publish data with restricted access, and they can still be accessible. They can still be fair. This is, for example, the case for privacy data or for medical data. What is the best practice here? To include a clear licenses and the conditions of use. Who is capable of accessing the data? Who can access your data and how? And the other thing is, if you are in doubt, if other researchers are going to be in doubt, the answer is no, they will not access your data. So always put a clear license. Interoperable. This is, I believe, in my personal opinion, but I think this is a shared opinion in the community, is definitely one of the most difficult requirement to meet. To me, it's also the most complicated word, but that's because I'm Italian. So what does this mean? Interoperable, or whatever you pronounce it, means that both people and computers, so people and machines, can visit your data and can interpret them and combine them with other data sets. If you think about the opportunities behind this, I mean, science could be doing amazing things. But of course, this is super challenging because you have so many data formats because of so many different reasons. So how are you going to do this? You have to document as much as possible. So this goes back to whatever we just saw about metadata annotation. Be generous. Don't be selfish. Be generous and annotate as much as you can. Use preferred file formats. So if you can choose between Microsoft Excel for a spreadsheet or a CSV, go for the CSV. Somebody on the other side of the world is going to be able to reuse that to open that. The other thing, if they exist in your discipline, you should use standard vocabularies, controlled vocabularies, and ontologies. And I will go and give you an example in a couple of slides. Just a week ago, I believe, the new FAIR sharing manuscript was released, a community approach to standards, repositories, and policies. I recommend you to read it. It's a great reading if you want to understand how metadata, ontologies, and vocabulary standards help achieve this type of principles. Of course, for the FAIR sharing, which used to be the biosharing, the main, let's say, focus are the life sciences, the biomedicine, but still there's a lot that other disciplines can learn as well. And there are right now 1,294 standards reported. Reusable, again, metadata and data needs to have accessible data usage license. So here the best practices are the following. If you don't know which type of license or how much you can open up your data set, check for funder, data repository, local policy, and institution obligations. Sometimes these obligations are in place and you need to know about them. If you have a set of of obligations that are not exclusive, consider multiple licensing. This means that you can potentially publish different versions of your dataset, opening them up with different licenses. This is a bit tricky, only do it if you know what you're doing. And the most important thing, avoid bespoke licenses. If you are not a license expert, like I am not, Just use whatever the community is building. For example, the Creative Commons. Go and have a look at the Creative Commons, look at the regulations, look at what they mean, and see which one you can reuse for your own purpose. You don't have to write a license if you don't know what you're doing. So my story, I will go now and give you a little example. Gareth asked me to introduce myself a little bit at the beginning of the webinar. I did not, because I don't like that, but maybe this is the exact time. So I am right now a data scientist. I did a PhD, I did a postdoc at Ghent University in Belgium, where I live. And basically the story of my PhD is that at a certain point I realized I was doing experiments and I was doing computational biology on a specific subdomain of cell biology, cell migration, so looking at how cells move, mostly cancer cells. And at a certain point I realized there must be so many research groups around the world doing all these crazy cool experiments. I want to have the data. I want to have the data because I have in mind the data mining algorithms and techniques I would like to use to extract as much knowledge as possible. Of course, this failed within 6 months because of a lot of limitations, which I will show you right here. So this is a workflow of a typical cell migration experiments from the sample preparation at the wet lab. Then you acquire images, you have time-lapse microscopy, you have a movies, you do image processing. In the end, you analyze your data, you report your results, you put them in your manuscript, you get it published, you even get a PhD out of it. And if you want to go one step further, it's a mess, or it used to be at least. It's a huge mess because everybody uses their own formats. Everybody uses sometimes proprietary formats which are not open. Downstream, everybody processes the images with their own piece of software. Some labs have no license for the software. And the most important thing, even at the very step, which is the sample preparation, a lot of metadata is not there. So you look at the data set, and actually what the data set means, you don't really know. So what we did, and that's really my story, towards fair cell migration data, we developed, we're still developing a series of community standards for cell migration data to get a bit closer to fair. Bear in mind, I'm not talking about open. Whenever possible, open is good. Sometimes this data come from patient studies and so on and so forth. So restricted access is also very possible. So what we did, basically, we developed a series of list, MyAcme, minimum information about the cell migration experiments. This is a simple checklist that should guide authors whenever you're going to publish a metadata set, a data set. Please fill in this checklist so whoever is going to look at your data knows what the metadata is. And then on the other end, for the 3 steps, experimental setup, the microscopy setup, and the analytical side, we developed 3 formats. To be honest, we already reused whatever was in the community. So we used the investigation study assay from the ISA for the experimental setup, the open microscopy environment for the microscopy, for the images, and then we just extended the tabular data package container format which was developed by the Open Knowledge Foundation. So basically what the Biotrax does, if you have your data as an output of your experiment, instead of having it in all those different file formats that I've shown you before, you have a package that converts everything into a CSV, which everybody can read, and a JSON file, which is also standardized. All of this needs to be mapped through controlled vocabularies. I will give you an example in a second. This is an example. It's on GitHub. You can have a look if you want. So it's one data set from one paper I published a couple of years ago. First and foremost, annotate, annotate, annotate. So be generous, put as much description as you can. And then you have, and then you have here on the 3 folders, one for the experimental setup, one for the MyAcme, and one for the TrackMate, and the companion file from the OMI, from the Open Microscopy environment. So this is how the MyAcme looks like. Basically, the information that you report has the cell details. Instead of just writing a B cell, you put in there CL000236. What is that? It's a standard ontology from the cell line that uniquely identify the type of cell, which is a B cell. Or the same for this ROCK inhibitor, which is a specific drug that inhibits cell motion. It's the chemical 7,5 blah, 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 blah. A machine will know how to read this. An API around the service will know how to read this. Expose as rich metadata as possible. This is the companion file from the microscopy side. For example, it says that the dimension order is X, Y, then it's the channel, then it's the Z, and then it's the time. You cannot mix this. And you know exactly what is the physical size in the X direction, what is the physical size of the image in the Y direction. It's micrometers and not millimeters. So again, as much as possible. Now, you might wonder, how are you going to make images data fair? That's not possible. They're not going to be machine actionable, but already being published with fair metadata is of very high value in its own right. So always keep that in mind. I have also linked here for you a tool which you can check to see how fair your dataset is. Like I said before, it doesn't have to be perfect. If you try this for the first time, it will not be perfect. It took me years of iteration with the community. But of course, if you go from using a web address, a URL, to using a unique persistent identifier, already a little step can make a huge difference. Like I said before, not everything has to be open, but if you do, and if you put enough focus and enough efforts into data management planning, a lot of sensitive and proprietary data can be fair. In this sense, I think that we, as a community, we should start talking more and more about data stewardship instead of management. Management, sometimes people believe that it's an IT task, that you do it and then you forget about it. If you become a data steward of your own data, metadata, that means you will also put love and care, responsibility and ownership in whatever you're doing. I put here this slide because there is a nice link to the ethics and data protection, which basically the European Respect Code, which basically highlights 3 key aspects. If you uphold your scientific standards, you try to be compliant with the law, so be informative, know about the law, and you try always to avoid the social and personal harm, don't worry, you're going to be good. This is the bottom line. Of course, if you wish to do everything like this and you don't have a plan, a goal without a plan is just a wish. So we have to have a plan. I'm going to go last 5 minutes to say, what is a data management plan? So some people believe that it's something very scary, that you're going to be able to be an IT person, to be able to actually write a data management plan. But it's nothing that's something that describes how we're going to organize, to structure, and to care about the information that you're going to produce in a research project. So I also believe that, like I said before, if we start talking about data stewardship, at a certain point, it shows people will show that they care about their own data. They will have to write a management plan. They will have to think about it, right? So the 2 questions basically that you need to answer when you plan a data management plan is, how do you look at your data day by day base? And what happens to the data after the research project finishes? These are the 2 main aspects. Of course, why should you do that? I believe that the love for your data should drive you. And I also believe that, as I said before, collaborate with less friction and collaborate with yourself with less friction. I believe ultimately you need to do a data management plan for yourself. I think this slide is there because I would like to give everybody a lot of incentives to do one. Ultimately, it's just for you. You have to do it for yourself. How do you do that? Here again, I've put a lot of resources. The main tool that you can use is the DPM Online, developed by the Digital Curation Center. A lot of public templates. What I suggest is that you look if they have a local version, if your university has a local version of the tool, which basically means that you can use your institutional account to sign in. And all the templates have been already in agreement with the Digital Curation Center, the DCC, have already been updated to keep in mind to take care about local funder policies, university regulations. So you make sure that you don't miss out on anything relevant. The 3 major things that I would like to tell you about a data management plan, try to avert a data storage disaster. Where are you going to store your data during your research? On your USB? No, absolutely not. On your computer? Absolutely not. You might not know about it, but chances are very high that the ICT department of your universities has a central file shares, and that's where you want to be. That's where your data want to be, because that has live snapshots, that has backups, and you don't want to have a data disaster in the middle of your PhD, of your research. You really don't want that. The other thing, how are you going to organize your data? And who better than Marie Kondo to tell you? Use directories. If you put in a directory the analysis file, the file that does the data clinics, the protocols, and the CSV of the raw data, this sparks joy. If you start replicating names, if you start don't using structure and hierarchy in your folders, this one does not spark joy. She still looks joyful, but way less. And here my tip, also as a person that works in IT, dry lab is know what your file is before you double click it. Before you even open the file, you know exactly what it is. Other people will know as well. The other thing is what formats and what software will you use? Now, I'm not necessarily saying that during your entire PhD or your research currently nowadays, you have to be open always, all the time. Sometimes things might depend on the hardware and the software of your research laboratories or the hardware of the software that you personally prefer. So during your research, you will most likely use formats that fit your own scope. After your research is completed, and for example, you start depositing your research objects into the web, then you should adjust to go for formats that are easy to share, easy to reuse, and they also enable long-term preservation. So chances are very like that if you're using a specific software, there is an option in there to export the format for something which is way more suitable for sharing or for long-term use. For example, sometimes crazy formats are just ASCII based. So what you can do, you can open save as.txt and anybody can open it. Not only anybody. So it's not only a matter of data sharing, like this cartoon here shows. It's also a matter of data visitation. So we're also starting in the community to talk more and more about data visitation, because it's the data sitting there and it's the machines starting to working on them, which is a bit goes back with whatever we talked about at the beginning about the e-science and the revolution that is happening. So I believe this for me ends it. Yes. And I will take question and I will stop sharing my screen now.
Thanks, Paola. I have a few questions already. And maybe what I'll do is just one or two simple ones to start off. And I see some questions related to metadata, what it actually means. Could you give a definition of what you understand as metadata?
Yes. So metadata is data about data. That's the official definition. So basically, this means that, for example, in my case, if I run an experiment in the lab, I look at how cells are moving. Then I have my data, which is a CSV file with position in time. But the metadata will tell me which protocol I used, which cell line, the software version that I used to acquire my images, downstream the Python version that I used to analyze my data. So everything that that describes the context in which the data was produced.
Okay, and coming back to another definition distinction, because I've seen it quite a lot myself and it's not always clear. The difference between data management and data stewardship. And I'll explain why I say data stewardship is a bit more complicated, because the steward can be the researcher themselves, but it can also be academic support staff.
Yes, I agree. So I don't know if that's a question you're asking me or you would like me to elaborate on it.
Yeah, what's the difference between, let's say, data management on the one hand and data stewardship, and then the two types of data stewardship, if they are different?
Yeah, so I believe that right now So it used to be up to a year ago a luxury for a research institution to have data stewards on site actually doing this data stewardship. Now it's less of a luxury, but it's still not so common. So it's still true that the researcher needs to pick up the responsibility of planning the data management and the data stewardship. I think that if there are data stewards in your research institution, you should definitely use their expertise. As a researcher, you should definitely use their time. Ultimately, the data you're producing is your data, right? It's the data, you know how you're producing them. And that's where I believe that the ownership and the taking care of comes in place. It's not only a matter of going to your computer. You open the DPM online, you prepare the data template, you fill it in, you make an export, a PDF, you give it to somebody, and you're done. It's not an IT task. It's not a task that you need to check out of a list. It's a continuous process. And this continuous process, of course, requires time. If you are a researcher, I understand that. And that's why if there is a data steward professional on campus, you definitely should use their expertise and their time. On the other hand, the time that it takes as a researcher, it pays off in the long term. As I said before, if in 6 months' time, somebody has had an idea, which has given you, again, an idea to rerun your analysis code in a different way, or to rerun an experiment in a different way, if you have put in place this data stewardship task for yourself, it's going to be way easier. Chances for you to be successful with that idea are higher by definition.
So your audience is not just other people, it's also yourself, basically, in the future.
Absolutely. I believe that's the main point. That's exactly why when I had this slide with why should you do a data management plan? Yes, funders, university policies, if you want to be compliant with the journal, compliant with the money, it's for yourself. The audience is you in the future, and just you, yeah.
I think that links to one of the questions that came in was the bigger question is how to incentivize early career researchers to put the effort into creating a DMP, a data management plan, or a good data set when they're already quite pressed for time and are busy with other activities. So how to maybe incentivize them even more.
Yeah, this is a tricky question because I know what it means to do a PhD. I know what it means to be an early career researcher, the beginning of your postdoc. I believe that there needs to happen a shift in the reward system. We all talk about it. It's out there. It's not publish and perish. Well, it used to be publish or perish. Now it seems to be publish and perish. I believe that the publish needs to be extended. So I believe that, as I said, so remember my first slide with the workflow, I have the advertisement, and then I have my code, my research workflows, my data set, my metadata, everything in between. Publish a paper is only a little piece of the cake. So things like promotions on data citations. If I release a good data set, which has a unique DOI and it's out there, and my data sets, it's so nicely curated and annotated that the entire cell migration community picks it up and they discover amazing science because they reuse it in a very smart way, I'm going to be credited for it, right? That's a reward towards me. I'm going to put it in my CV. It's not a publication in the traditional sense. It's a data set which is, published. But then, of course, we have to make sure that dynamic citation happens, that these citations get tracked. And that's why the Research Data Alliance has a dedicated working group on dynamic data citation. There's a lot of things that needs to happen. But definitely, we need to start to evaluate early career researchers for more than publishing papers.
Okay, so not just that researchers are rewarded for publishing articles, but that they get rewarded for maybe publishing peer reviews or, for instance, publishing data or making data fair or opening up these other outputs, even their methodologies, right? Or protocols.
Absolutely. Have a portfolio of, people, when you have to graduate, you have to present a list of the research articles you have published. most likely with the impact factors, but that's another story. Why can't you also present to your faculty committee a list of annotated, fair data sets you have put out there, which people in the community have peer-reviewed, criticized, most likely reused for innovative things? Why is that less valuable than publishing a text?
Yeah. So to be clear, Eurodoc fully supports this. This is what we're trying to push, but I think we're a little bit off this for a while. This really needs to be put through at university, even national level, right? To get people to change their mindset here.
If I can throw something into the hat,
Ivo?
yeah, can you hear me well? The two things, the intrinsic motivation of doing these things for yourself should be the driver, and I'm trying to accessorize that main argument with smaller arguments on different timescales in case you are swimming into a more skeptical environment, or you're trying to convince a young researcher against their gut instinct. So in that context, I have two things really to offer. One is that the change in the reward system is not that far off into the future. You may have heard about it. There's a lot of talk about it. There's all sorts of declarations you might come across that people are frustrated that they don't moving fast enough into the real world. But there is a sign that you can point to that things are changing, and that is the field of psychology. There's at least a dozen universities that will recruit professorial chairs, and as part of the recruitment criteria, they are asked to demonstrate a track record in open science, and that means uh, data stewardship, publishing more than just the research results in high impact journals, supporting young researchers to understand and practice open science, and that's unprecedented. And if you understand how trends move in an exponential curve, just do the math, and by the time you're in mid-career, the landscape might very well be very different. So that's a bit of a mid to long-term argument. Um, in the immediate, time frame, I would say DMP. Yes, it looks like a lot of house cleaning. It takes a lot of time away from other important things. But I'm here at this society offering this clinic directly to early career researchers to demonstrate to them that everything that just came out of Paula's mouth will help you win a grant. And that's an immediate incentive if you want to stay in business. All of these tasks that look like a lot of time, a lot of house cleaning, uh, um, we can show you how you can win grants with them just because you are proactive, above and beyond the competitors. So in that sense, while you're waiting for the reward system to change, here are a set of tools that you can help you win grants while the system is changing.
And Ivo, maybe you can share the link somewhere with the webinar that was done, I think, with us on winning Marie Curie grants using open science, right?
Sure. Yeah, we'll follow. We'll share that at the end together with any other resources.
I'm going to jump back to Paola on PIDs, personal identifiers. And can you tell us a bit about ORCID? And can I use ORCID for data?
Is that a question, a genuine question? No. Okay. So what ORCID does, it's so what does it stand for now? I will have to look it up again because me and the short answer is no. You cannot use it for data. It gives you a digital object identifier. The object in this case is a researcher. So it identifies uniquely a researcher. So this means that if you have two or more people with the same name around the world, their ORCID will be unique. And if you list your ORCID in your list of publications, in every new publication you publish, they will know in an unambiguous way that that will be you. What else can I say? I hope that, I believe nowadays everybody has an ORCID.
Not everybody. So I think maybe one thing we can say is to get all our ambassadors to make sure that they register for an ORCID ID.
Absolutely. Yes. Yes.
Oh, the question was like linking on, because ORCIDs are used mostly for articles, but could we not use an ORCID to link to a data set so that I can find the person who's behind the data set and then also somehow reward them for it?
Wait, you mean if you can use a PID, a persistence identifier? Because the ORCID is just, so ORCID is a very specific identifier, digital identifier, that it's meant to track researchers as human beings. But a persistence identifier, yes, it can also be used to track a dataset. For example, the dataset I've shown you, my very first FAIR cell migration data, that it's published on GitHub. That, of course, is a URL. Then what we have done, we have in Zenodo, which is a generic purpose repository, you can basically attach that GitHub repository, you can associate it with a DOI. So there is a digital object identifier that tracks that specific data set. If somebody is going to use that, that DOI says Gonzalez, Masuzzo, et al., that will be me. That counts me as a citation. Of course, the way these citations then are collected, we're not there as much as we are with research articles, right? So, Google Scholar and indexing, we're still working on it. But already to assign a persistence identifier to datasets, it's possible, and it should be done.
And one of the questions was, what other useful types of PIDs are there other than, for instance, the DOI, the digital object identifier?
Oh, there are a lot. There are even way too many. The handles, for example, there are really a lot. Sometimes it really depends on the technical implementation. I'm not really a technical person, so I wouldn't really know. But it depends. It depends on the repository, for example. Depending on technical implementations, a specific repository might prefer to use a specific persistence identifier rather than another one. But from a researcher point of view, shouldn't really matter. I wouldn't really care which type of persistence identifier I'm going to be using. If you deposit your data in a trusted, certified repository, you will have a PID by default. That could be a DOI, that could be something else, but you will have a PID. And the way the PID is structured is standardized. So you will always have the reference, where is it coming from, the ID of the object, where is it pointing. But this really depends on the semantics of the web. We will have to go very technical there, and it's not really my expertise.
Okay, so that in many cases, that's actually done for you, depending on where you deposit your data or your article even. Linking to that, the question is, what if I deposit my data in a repository that is very bad regarding SEO, search engine optimization? That is, if someone Googles my data set, they won't find it. And should I also add entries for the data in other repositories?
Yeah, you should. So actually, I would answer to the question with why would you choose that repository? What is the main decision then? Why did you choose that? If there is a reason that you really cannot do that, then consider also deposit the same data set to different repositories, because one of the principle of the findable, or it's the accessible, no, I think it's the findable, you need to be sure that the data set is searchable. If it's out there, but the search engines don't find it, machines will not know, and humans will not know either. So if there is a really specific reason for you to still use that repository, funder mandates, local policy or whatever, do it and check if it's possible to publish it to something else which is more searchable and better indexed.
Okay, so you need to basically check that the repository is trustable. And I think you mentioned the RE3 data. Is that a good place to start?
Yes, start from the re3data.org. That's the registry of data repositories. Now, I don't know how many are listed there, but really a lot, depending on research domain, depending on, I think I even put the link on the slide.
Yep.
So if you look there, you can search. There are a lot of resources. You can search for a subject, content type, country. So if you have a specific limitation on my data should stay in Italy, it cannot leave Italy, then you can search by country and then by domain subject. And you also see there, let's say, how repositories are valued in terms of long-term preservation and trustness and how well they are indexed and this type of things. Now?
Yeah, now it's back. There was some slight feedback. A question is, does citation of your data sets or can citation of your data sets impact your Scopus or Google Scholar H index today?
Your Google Scholar H index. Oh, that's a good question. I don't know.
I don't know the answer to this, by the way.
You do know?
No.
It's a good question.
If I'm not mistaken, you can accept or reject in Google Scholar whether a certain object is yours.
Yeah, absolutely.
So
search object, if it's tracked back to you, Google Scholar can map it. You will see it in your profile. But I'm not necessarily sure the H index computation will pick it up.
Computation, yeah.
That's
good question.
But it can definitely show up in your profile on Google Scholar.
And it's a fair question, but it goes against the good faith of why we're doing this. We shouldn't gamify the process. But it is a fair question.
Sorry, try again. Question related to training and support. So should data stewardship be part of a PhD training course, and should data management plans be obligatory for a PhD project?
I don't know if this is going to be an unpopular opinion or not, but the answer is yes to both. The answer is yes to both. You cannot start early. I have started quite late in my PhD and I have paid for it. So yes, I believe that this should be something that needs to be discussed and needs to be part of formal training. One of the resources that will be available soon for the Open Science MOOC is the Fair and Open Data module, we just started working on the development on. I think I'm going to be pretty busy with that. And if a PhD student should have a data management plan mandatory, yes, I don't like the term mandatory because it makes it sound like it's a stick and not a carrot. But if you do your research, you have to report to doctoral schools every 6 months, every year. You have to report to your PI about your results. You have to write articles and submit. So I understand it's a lot, but it's something that really pays off. So yes, it should be mandatory.
Just to be clear as well, Eurodoc has actually supported the use of training and support for data stewardships in doctoral programs. And I mean, we don't like the use of the word mandatory either, but we do think that a data management plan should be part of each project. And it does not mean a fully detailed plan, but some kind of. I'm going to close off. I just would like you to give some final tips, if you can do that very short, for the early career researchers for data management.
I think I have only 2 tips. One is don't be afraid, do it. The data are not that scary. And the second is it needs to be good enough. It doesn't need to be perfect. Strive for good enough. Every little step counts. If, as Ivo said at the beginning, you go back to your research lab, your research environment, and you don't feel necessarily supported, and all of this is starting to make you feel stressed and not that easy with yourself, step back, don't do it. As long as you can, you should.
Thank you. Then I'm going to wrap up here. I'm going to say thank you to our co-organizers of the training, Ivo Grigorev and also Roberta Moscon on the other side on YouTube. And I'm going to say goodbye to all our ambassadors. And in our next webinar, we'll discuss Plan S with Mark Schiltz. Thank you, Paola, for this presentation. And if people have questions, they will get in contact with you.
Thank you.
Thanks, guys. Have a nice day.